You are not failing accessibility because you don't know WCAG. You are failing because you are exhausted by the time you reach the success criteria that cause 80% of real issues. And this video fixes that. But don't get me wrong. I'm not saying that other success criteria don't matter. But the ones we are covering today are responsible for nearly 80% of the real accessibility issues. Which means if you are not testing these, you are very likely shipping inaccessible experiences, even if your audit looks clean. By the end of this video, you will know which success criteria actually matter most, how to test them properly, how to fix them, and which persona or people with disabilities are most impacted. So watch this video till the end and subscribe to master web accessibility testing in 2026. WCAG 2.2 has around 87 success criteria across single A, double A, and triple A. In the real world, large organizations focus on single A and double A because those are the levels that are practical to achieve. And here's the problem. When everything is treated as equal, nothing gets tested deeply. So in this video, I have done something different. I have organized most impactful WCAG success criteria by principle to keep testing focused, repeatable, and realistic. These aren't random picks. These are the criteria that break real user journeys, show up again and again in audits, and separate professional accessibility testers from checklist testers. Before we go further, comment checklist or master. Which tester are you trying to become? Now this is important. You don't start here. You start after automated tools like XDevTools and ANDI have done their job. This is the layer that comes next, where usability breaks and real users feel it. Let's start with the first principle, perceivable. In simple terms, as a user, I must be able to see it, hear it, or feel it. If users can't perceive it, nothing else matters. Non-text content at level A. Here's the mistake I see constantly. Every image either gets meaningless alternate text or worse, everything is marked decorative. And just like that, the entire reason we distinguish between informative and decorative images is completely destroyed. Don't guess, test it. Run ANDI and see what it thinks the image conveys. Turn on a screen reader, navigate image by image using G, and then ask one brutal question. Does this alt text explains why this image exists? If the answer is no, it's broken. Write alt text that preserves meaning, not appearance. For truly decorative images, give them empty alt text. Alt equals empty on purpose? That's not laziness, that's intent. This criteria impacts screen reader users and people with cognitive disabilities. Anyone relying on content and not visuals. Alternate text isn't about images, it's about preserving information. Comment below who should define alternate text. Designers, content authors, or developers. And if you want to learn how to write effective alternate text for every image type, watch my full video. It breaks this down step by step. This is where your beautiful design silently fails people. I have tested pages that looked perfect. Clean sections, bold headings, tidy lists everywhere. But when a screen reader users landed on the page, it was complete silence. Because those headings were just styled divs. No real semantics, no structure, nothing for assistive technology to grab on. Press H to jump through headings, skipped. Press L to find lists, nothing there. What looks organized visually becomes invisible to screen readers. To test it, run ANDI and check for real headings and lists. With the screen reader on, press H for headings and L for lists to jump from one heading to another and one list to another. Stop styling containers to pretend they are headings. H1 through H6 for meaningful heading structure. UL or OL tags for unordered and ordered lists. This success criteria affects both screen reader users and people with cognitive disabilities who rely on predictable structure. And this is one of the most common failures in real accessibility audits. If color is doing all the work, you have already excluded users. This is exactly what use of color is about. If your product relies on red text alone to say out of stock or green alone to mean available, then you are assuming everyone can see and interpret color the same way, but they can't. For many users, color is invisible, unreliable, or misleading. Simply turn on ANDI's grayscale view or imagine the page in black and white. And now ask yourself, would this still make sense if color did not exist? If the answer is no, it's failing. Never rely on color alone. Pair color with clear text, icons, or patterns, so the meaning is obvious to everyone. This affects colorblind users and low vision users. Color should support meaning, not carry it. Accessibility does not fail in edge cases. It fails in defaults. This one shows up everywhere. Buttons, error messages, and labels. You must check color contrast on text and interactive elements, not just body text. Work with your designers to adjust color and not font size, because bigger text does not fix poor contrast. It just makes the problem louder. This success criteria affects people with low vision or anyone using your product in a bright daylight. Hi, I'm Param Singh, and everything you're hearing comes from testing real products with real teams. Once users can perceive content, the next question is simple. Can they actually use it? And that's our principle number 2, operable. As an end user, I must have the freedom to choose either a keyboard, a mouse, or a switch device to interact with your website. Let's be clear, if it doesn't work with a keyboard, it doesn't work with a screen reader, period. To test it with the keyboard, simply use Tab, Shift Tab, Enter, and Space. If these are working, you have a good solid start. Ensure your developers have used semantic HTML tags and have removed any keyboard traps. This success criteria affects people with motor disabilities and screen reader users. I once tested a sign-up flow that passed every automated check, but a keyboard user couldn't even reach the submit button. Technically accessible, but functionally useless. Comment keyboard failure if you have tested such websites. Navigating repeated content is visually annoying, but for keyboard users, it's exhausting. Imagine tabbing through the entire repeated block of content on every single page, again and again and again. That's not friction, that's fatigue. To test it, start tabbing from the top of the page. Do you see a skip link? Does it actually work and take you to the main content? Turn on your screen reader and navigate by landmarks. If you are able to jump from one landmark to another, your structure is doing its job. If not, the page is forcing users to work harder than they should. Add a skip to main content link as the very first focusable element in the DOM and make sure it works. Then use proper HTML landmarks so users can move through their page efficiently. Accessibility does not fail because users can't adapt. It fails when we forget to design for how people actually navigate. For keyboard users, focus is their cursor. It's how they know where they are, what's active, and what comes next. Remove it, and they are suddenly lost in the interface, guessing instead of navigating. To test, put your mouse away and navigate using only the keyboard. Can you clearly see where your focus is at all times? If you can't track it visually, neither can your users. Never remove focus tiles with outline none unless you provide a clear, visible replacement. Focus must always be obvious, consistent, and easy to follow. If focus is invisible, the interface is invisible. Click here link text is like your mom saying, call Sharmaji. Which Sharma? Your neighbor, your Kriana store uncle, or your tuition teacher? That's exactly what screen reader users hear when every link says, click here. No context, no meaning, just confusion. List all links by opening the links menu. Read them. Do they make sense on their own? We must write link text that explains the destination clearly. If your link needs surrounding text to make sense, it's already broken. This is my new favorite WCAG 2.2 failure. And once you see it, you can't unsee it. You press tab, focus moves, but you can't see where it went because it's hiding behind a sticky header or overlay. Visually, It feels like the interface just swallowed your cursor. But for keyboard users, that is the cursor. Tap through the page with sticky headers or banners. If focus disappears even for a second, it's broken. Adjust the layout so the focus is partially hidden. Now there are exceptions which I have covered in this video. Tiny targets create invisible barriers. Designers assume personas with perfect hands, perfect vision, and perfect control. When users try activating those tiny buttons on a moving bus with tremors, suddenly nothing works. Ensure your target size is at least 24 by 24 pixels. Now there are exceptions and I shared my strong opinions in this video. If you have caught these issues earlier and can completely resonate, please give me a thumbs up. I make this content to help you master accessibility, and you can support me by becoming a channel member. It helps me create more hands-on real-world content that moves you from knowing WCAG to actually mastering web accessibility. Now, if users can operate the interface, the next question is, does it behave in a way they can understand? Understandable principle is all about providing consistency, helping them avoid create issues, and simplifying content on the page. Let's begin with the first success criteria. Have you ever heard a railway announcement in the wrong language? Same words, but completely wrong meaning. That's exactly what happens when page language is incorrect. If your website content is in Hindi, Tamil, or Arabic, but the page is marked in English, screen readers sound broken. They care about the experience. They will think that this site is unusable. Simply inspect the HTML language attribute and set the correct language attribute using the two language codes, because two language codes are universally accepted. Next two success criteria fail together. If you miss one, it's highly likely you will miss the other one. Imagine opening an e-commerce website. You're tabbing through the page and you land on the buy now button. And suddenly the page refreshes, the cart updates, or a pop-up opens without you pressing enter. That's not speed, that's chaos. For keyboard and screen reader users, focus is positioning, not permission. Nothing should happen just because something received focus. To check, tab slowly through the page. If a new tab opens, or a model opens, or an action is triggered without your interaction, actions must be triggered on explicit user input, like enter, space, or click. Focus should guide users, not surprise them. Similar to on focus, change of context must not happen on input without warning. Try writing into a text box. If it changes the context, such as opening up a new page, opening up a model, putting focus on a different control, or changing the entire meaning of the page, your on input success criteria is broken. Help should never feel like a scavenger hunt. On one page, contact us is in the footer. On another, it's hidden behind a menu. On checkout, it's completely gone. And for many users, especially screen readers and cognitive disability users, that inconsistency is exhausting. If help exists, it must appear in the same place every time. Predictable help equals confidence. Inconsistent help equals frustration. Accessibility isn't about adding help everywhere. It's about making help easy to find every single time. Now, this is not applicable for tooltips. Watch this video for more details. You tab into the first form field. It's empty. No label, just a blinking cursor. Now you're left wondering, is it asking for your full name, your email address, or your phone number? And when you submit, the form says invalid input. That's not user error. That's missing instructions. Users must know what a field expects before they interact, not after they fail. A simple fix is to provide clear labels or instructions that persist. Never rely on placeholders alone. If users have to guess, the form has already failed. Errors without guidance are dead ends. They tell users something is wrong without telling them how to fix it. And that's how users get stuck. Not because they did something wrong, but because the interface stopped helping. This impacts people with cognitive disabilities, screen reader users, or anyone unfamiliar with the form or language. To test it, submit the form with an error. Listen or read the message. Does it explain what went wrong and how to fix it? If it only says invalid, it's broken. Pair every error with clear, actionable guidance. Explain what's expected and how to resolve the issue. Error messages should teach, not punish. You already gave your name, your email, your address, but at checkout, the form asks for everything again. That's not confirmation, that's friction. Re-entering the same data is a real barrier. This impacts people with motor impairments and people with cognitive issues. We must provide mechanisms such as autofill when possible. Let users review and edit and not retype. Our last principle is robust. As a user, I must have the freedom to choose any operating system, any device, any user agent of my choice. Let's look into the success criteria: name, role, and value. You land on a button and your screen reader says clickable. No name, no role, no value. That's not a control, that's a mystery. Assistive technologies must know what an element is, what it does, and its current state. This impacts screen reader users and speech input users. For this menu item, our accessible name should be home, role is a link, and state should be collapsed because it is in the collapsed state. The simplest way to achieve is to use native HTML controls whenever possible and combine it with ARIA attributes for ARIA expanded true or false states. If assistive technology can't understand your UI, neither can the user. And when the user clicks on save, nothing announces and nothing is confirmed. They are left wondering whether it worked or not. And that silence is the barrier. Status changes or any dynamic changes happening on the page must be announced to a screen reader user who rely on feedback. If dynamic updates are not announced, they are failing end users. Make use of live regions like ARIA Live or Role Alert. If the UI updates silently, users are left guessing. Accessibility is the system. Every success criteria matters. But if you want real impact, you start where most real-world barriers actually come from. Test these success criteria early and then move on to the rest. If this helped you see testing differently, like it, share it with your team, and comment which success criteria troubles you the most. Let's remove accessibility barriers together.